Okay, hello, good evening. Yeah. Very soon we're going to be starting. And today we're going to be looking at chemistry. Yesterday we looked at physics. So today we're going to be starting with chemistry. Once it's 6 o'clock on the dot, we are going to be starting. So I'm going to leave us time to join up. We'll start by sharp 6. We just have 5 minutes before the top of the hour. Please sit down. You should read for you.
Not now. Backdrop, no to me. This big banner inside the hall. We put it at the.
Okay.
Can you do banana?
Oh, we can also do it today. It's possible.
That's good.
We'll do the design now.
But we are not the cost. Pour
Let
that in the mixture.
me see this side.
10 by 10. Okay, this one should be 10 by 10, should be something like this. Up, down, like that. So from beginning of this place, this one, and go up, down.
What the design and printed 15,000.
What if we bring our design?
To bring your design.
Like, what if we all our data to send us? Let's present the options. We're here for it, remember.
Okay.
You know, we are here before one session. The case is not able to change banners, to correct banners. So please, because we have not yet, sorry, we don't feel like we have accepted the price because we are going to get it.
Hello and welcome. So let's quickly start. Is sharp 6. So today we're going to be looking at chemistry and we're going to be starting with knowing what chemistry is. Okay. Okay, some people are joining. Onafua Oluwaseyi. Yeah, please make sure you're mute. Once you join, make sure you're mute, please. Okay, welcome. Good evening. Today we're going to be looking at chemistry. And we're going to start with what chemistry is. So chemistry is that branch of science that deals with the study of nature, composition, and properties of matter, and also the changes that matter will undergo under different conditions. So when you see chemistry in life, how does it come about? So you have your nails, your iron nails, you see them rust. So when you have a new time due to water falling on it and other things, it gets rusted. So that very rusting of nail can be explained using chemistry. Also, your palm wine, when you freshly tap your palm wine, you can see that the taste is very sweet. But after some time, the palm wine will sour and the taste will no longer be good. So that is, chemistry can explain that. So how the palm wine goes about souring, we can explain it with chemistry. Also, burning of substances, which we'll call combustion. So this is brought about by when there is ignition and when there is oxygen. So chemistry can also explain what burning is all about. Okay, so let's move forward. Now, according to your syllabus, you're supposed to know how you can test for purity. Pure substances, how do you know them when you come about them? So there are many ways of testing for purity. The most important 2 ways of testing for purity is using what we call melting point and boiling point. So for substances that are very pure, if they are, say the melting point is 100, immediately it gets to 100, it will melt. But if it is not pure, you might see it melting at 120 degrees or at 90. So accuracy in the melting point determines whether a substance is pure or not. Then for substances that boil, their boiling point also determine whether they are pure or not. Pure substances, they boil at a specific temperature. So say a substance is supposed to boil at 90 degrees Celsius. If it goes and boils at 70 degrees, that means that very substance is not pure. So JAMB is going to ask you, or WAEC is going to ask you, which of the following can be used as test for purity? They will have melting point, they will have solubility, they will have density. Mostly for liquids. We know that impure substances melt or boil over a temperature range, whereas pure substances, they melt and boil at a fixed temperature. So also note that a pure dye gives only one spot on the chromatograph. So if you're checking coloring materials like dyes, it has to give one spot on chromatograph. And it has a sharp melting and boiling point. And are you following? Anna, did you get what I just said now? If you want to talk, you unmute yourself. Can you see where the road? Anna, can you unmute yourself? Try and unmute yourself so that. Can you do that? Okay. Oluwase, I want you to give me the 3 ways of checking whether a substance is pure or not.
We can check whether a substance is pure by using the melting points or the boiling points.
Good. So that is how you check. Use melting point for solids, boiling points for liquids, and for colored material, the spots they have on the chromatograph. So those are the 3 ways of checking whether a substance is pure or not. Okay, that is test for purity. Now, what is this boiling point? When we talk about boiling point, what is boiling point? Whenever the molecules of the liquid acquire greater kinetic energy, and they tend to evaporate. So at that state, you can say that the liquid is boiling when the vapor pressure of the liquid is equal to the prevailing atmospheric pressure. So bubbles of vapor can be formed freely in the liquid and rise to the surface. So the boiling point of, say, a liquid like water is 100 degrees Celsius, whereas that of ethanol is 78 degrees Celsius. Now, melting point. When vibration overcomes the binding forces, this time around for solids, the particles become mobile. So the crystalline structure then collapses and the liquid state is freezed. So that is when we talk about melting point. Now, quick elements, compounds, and mixtures. Very, very important. We're going to be covering a lot. So today we'll look at element, compounds, and mixture test with separation techniques. So you see, today is going to be very, very filled with a lot of things that will help you passing your JAMB and WAEC. So elements, an element is a substance which cannot be split up into simpler substances by any known chemical means. So every element substances by any chemical means. And there are about 106 known elements. And these are scattered in different percentages all over the world. The seawater contains higher percentage of dissolved oxygen than nitrogen. Now we look at compounds. We've already established that elements cannot be split into smaller substances, okay? Compound is a substance containing 2 or more different elements. So when you have what we call compound, and they come together, they are chemically joined. So most substances occurring in nature are actually compounds. Example of compounds and component elements are stated in the table below. You can see the compound marble, like you use in your house, is actually made up of calcium, carbon, and oxygen, chemically combined together. So that word is very key. When elements chemically combine together, we get what we call compound. A very good example of another compound that we have is caustic soda. So caustic soda is a combination of sodium, oxygen, and hydrogen, a very, very important compound that you use every time in the lab and other places. Then we have also another chemical known as caustic potash, and it's composing of potassium, oxygen, and hydrogen. You can see caustic soda has sodium, but very importantly, oxygen and hydrogen, whereas caustic potash has potassium, oxygen, and hydrogen. Now, another very important compound is the sand. Every one of us know about the sand. So the sand is made up of silicon and oxygen, very, very important. Then another very, very important compound is the glucose. The glucose is very important, both in the metabolism, what goes on in the body, and we taking in the glucose to get energy. If you're doing any physically intensive exercise, you will need glucose because glucose helps you produce energy very fast. So what is this glucose made up of? What are the elements that come together to chemically combine to form glucose? You have carbon, hydrogen, and oxygen. Then very importantly, we have another compound known as ethanoic acid. So ethanoic acid is simply, when you talk about ethanol, some people call it ogogoro, some people call it kai. So this ethanoic acid is actually composed of carbon, hydrogen, and oxygen. Just the same way glucose is composed of carbon, hydrogen, and oxygen. Then there is also calcium chloride, making up of calcium and chlorine. And we have the bleaching powder that consists of calcium, oxygen, and chlorine. And finally, a very, very important acid known as tetraoxosulfate 6 acid that is composed of hydrogen, sulfur, and oxygen. So these are the very most important compounds that you have in the world. You meet them every day, and it is important that you know the elements that they are made up of. Okay, let's continue. So let's look at mixtures. So the topic for this is elements, compounds, and mixtures. So we've looked at elements. We said we have about 106 of them, and we gave examples of them: oxygen, hydrogen, and the rest. We looked at compounds. Compounds are chemically combined elements. Now let's look at the third one, mixtures. What are mixtures? Mixtures, or a mixture, is from when two or more substances physically join together. So I want you to get the difference between a compound and a mixture. In a mixture, they are physically joined together. That means you can use separation techniques to separate them. But in compounds, they are chemically combined together. That means you cannot use simple separation techniques to take them apart. So take note of these two forms of substances. So it's either a substance is a compound or a mixture. In mixture, they are physically combined, whereas in compound, they are chemically combined. Okay, so let's move forward. They are not actually chemically joined for mixtures, and the environment we live in is composed of a mixture of all forms of matter. For example, the air. So the air is a very, very important mixture, and you need to know what the air is composed of. The air is composed of nitrogen, it is composed of oxygen, it is composed of carbon dioxide, it is composed of water vapor, and it's composed of other inert gases. So the air is actually a mixture because the component substances or the things that make them up, they can easily be separated using physical means. Okay. So the air is a mixture of different gases. The earth that we live in is a mixture of soils, rocks, minerals, living organisms, plants, and animals. So the earth itself is also a mixture. And the sea that you use, the big seas that you travel on, or if you want to swim, that you go to swim, the sea is also a mixture of water. salts and dissolved gases. So that is what the sea is made up of: water, salts, and dissolved gases. So the components of a mixture may be elements or compounds. So actually, the components of a mixture can either be elements or compounds, but these elements and compounds are joined together physically. They are not joined together chemically. So take note. So let's look at the most important mixtures and what they are made up of. Number one, we look at the seawater. The seawater, where you go to fish if you want to fish, or if you want to travel from one community, like in the riverine area. So that seawater, what kind of mixture is it? What kind of compounds or elements or substances that come together to form the seawater mixture? So for the seawater, you will have the water, that's the fresh water itself. Then you have the mineral salts. Then you have the dissolved air. Then we have bacteria. So these are the things that come together to form the mixture of seawater. Now let's look at the air. I've already talked about the air. The air is made up of nitrogen, oxygen, carbon dioxide, water vapor, inert gases. Now, petroleum is another very, very important mixture. And why is petroleum very, very important to those of us here in Nigeria? We know that petroleum, crude oil, is where Nigeria gets close to 90% of its revenue. And this crude oil is in the Niger Delta. And there are refineries around the Niger Delta and one in Kaduna. And Dangote is building one currently in Lagos. So petroleum is the most, I think, is the most important commodity to the nation Nigeria. And that is why we need to know the components of this petroleum that we'll get. So petroleum is made up of several components. And that's why when petroleum undergoes refining, and later on we're going to find out that the refining simply means is a method of separation known as fractional distillation. So when petroleum undergoes fractional distillation, it's going to give us these components that actually constitute the petroleum. So what are these components? So number one is what we call the petroleum gas. The gas. We use this gas in driving some of our cars. Then we'll have the petroleum ether. We have the petrol itself, the one that we use to fuel our cars. If you want to drive your car, you use petrol for that. So petrol is one component of petroleum or crude oil. So when you hear the word petroleum, we simply mean crude oil. But when you hear the word petrol, that is the gasoline that you use in your cars. So apart from petrol, we also have the kerosene. All of us know about the kerosene. That's what we use in our houses to cook food. Then we have diesel oil, diesel. So diesel is what we use in all these big cars, big lorries. So you can see that from the single crude oil or petroleum that you get from Niger Delta, you can get all these different components that are used by different automobiles. So for the diesel, you have the diesel engine lorries using them. For kerosene, you use them in the house to cook food. For petrol, you use in your cars to drive. Okay, so those are the components of the petroleum. So when we start looking at separation techniques, you're going to find out that separation techniques are simply the techniques that you can use in separating mixtures. So let's go to the next important mixture known as palm wine. So what is the palm wine? You drink palm wine all the time. It's very sweet. So what is palm wine made up of? Palm wine is made up of water, sugar, yeast, protein, fats, vitamins, and minerals. So you can see that palm wine is actually constituting of very, very, very important. When we talk about fermentation, how the palm wine sours and the rest, you're going to find out that some of these constituents play a very big role in that. Now let's move forward to the next very important mixture, and that is milk. So milk is made up of water, sugar, fat, protein, mineral salts, and vitamins. Then we look at urine. We all know what urine is. Human beings pass out through urine. So urine is made up of urea, water, and mineral salts. Then very importantly, we look at bronze and brass. So these are alloys of, for bronze is copper and tin, whereas for brass, it is copper and zinc. So whether it's bronze or brass, two of them starting with the letter B, they are always composed of copper. But for bronze, it's copper and tin, whereas for brass, it's copper and zinc. So these are the most important mixtures that we need to know about. Now, this takes us to the next concept that we are dealing with today, known as physical and chemical changes. So changes matter. We all know that matter is anything that has mass and occupies space, just like this water I'm holding. So this is matter because it has mass. I can feel the mass, which can be related to the weight, and it's occupying the space. This is matter. This, my mouth here, is also matter. Even me, myself, I'm also matter. So matter is anything that has mass and occupies space. And this matter undergoes two basic types of changes. Those changes are known as physical or chemical. So in chemical change, it is permanent and it cannot easily be reversed. Whereas in physical change, you can easily reverse it. So let's take an example of a physical change. If I have water here inside this and I put this very can, like I'm having, this is water. If I put it in my freezer and I on the fridge, after some time, this water will turn to ice. So when I bring it out, you will see that I cannot be able to press it in because the water has turned to solid, from the liquid water to solid ice. So that is a physical change. If I take that water that is ice and go and keep it under the sun, after some time, the ice will turn back to the liquid, and that is change. It has reversed from turning from liquid to ice, which is solid, and back to liquid. So this is an example of a physical change, something that can reverse. But when you look at something like rusting, you bring your nail, the newly brought nail is very shiny. After some time it rusts, you cannot get it back to being shiny, and that is chemical change. So take note of these two types of changes that matter can undergo, either physical or chemical. And that brings us to the main topic of today, which is separation techniques. Separation techniques. And I told us that separation techniques are actually used in separating the different strengths of a mixture. Technique to separate compounds that are constituted of chemically joined elements. You can only use separation techniques or separation techniques to separate the components of a mixture which are joined by physical means. So what are these separation techniques? We're going to be starting with evaporation, which is the simplest. Oh, not actually the simplest, because we have sieving, we even have hand picking, we have filtration and the rest. But let's start with evaporation. Evaporation is a method of obtaining a soluble solid from each solvent. The mixture of the soluble solids, such as salt, with solvents such as water. So salt can dissolve in water. That's why we say salt is soluble solid, whereas water is the solvent. So when there is a mixture of a soluble solid and solvent, we have what we call solution. So in such a solution, when you apply temperature rise, you will see the solvent will start to evaporate, leaving the solutes, and that is evaporation. Very, very important way of separating soluble solids from their solvent. Then number two, we look at fractional distillation. I'm going to show us the pictures that have all this so that we can understand this better. So fractional distillation, like I said, this is the method you use in separating two miscible liquids. So I want you to get this, two miscible liquids, like the liquids that you have in crude oil. All of them are miscible. That's why when they come together, they form crude oil. You see crude oil is mixed together. So how do you separate them? Those miscible liquids, you use what we call fractional distillation. So once those miscible liquids have close boiling point, you can only separate them using fractional distillation. So it is the most important method used in separating crude oil into paraffin, petrol, diesel, cooking gas, which are the constituents of the mixture petroleum or mixture crude oil. So fractional distillation is used in separating two miscible liquids with close boiling point. And how does this question come about in JAMB? They are going to ask you, the mixture in crude oil can be separated using dash. You have evaporation, you have distillation, you have sublimation, and you have fractional distillation. So you should be able to pick out fractional distillation as the right answer, because that is what you use in separating two or more miscible liquids with close boiling point. Now let's look at distillation. Distillation is used to obtain a solvent from a solution. You see that evaporation is used to obtain a soluble solid, that's the solutes from the solution, from the solvent, whereas distillation is used to obtain the solvent from the solution. So when salt solution is evaporated to this dry solid, the water vapor, instead of escaping into the atmosphere, can now be passed into a second container and allowed to cool. Now let's look at sublimation. Sublimation is a method used to separate a mixture which contains a substance that can sublime. So in using sublimation, you must make sure that one of the components of that mixture can be able to sublime. This simply means that a solid substance that can change from solid state to gaseous state. Sublimation simply means the ability to change from the solid straight to the gaseous without passing through the liquid state. Okay. Then we also have filtration, and filtration is a method of separating an insoluble solid from a liquid by the use of a filter paper. An example of an insoluble solid is sand. So if sand is mixed with liquid, you can simply filter out. That's why we normally use filter paper to do that. Okay, then there is also crystallization, which is used to separate salts which decompose easily on heating from their solution. So when you want to separate a salt that can easily decompose, you don't want to apply heat, please use crystallization. So salts like iron 2 tetraoxosulfate 6 heptahydrate and copper 2 triosonitrate 5 trihydrate, all those, or copper 2 tetraoxosulfate 4 pentahydrate. So the salt is heated first to drive away some of the solvent, but you don't heat it so much, because once you heat it so much, it will decompose. So once you do soft heating to drive out some water, then you use crystallization to get your salt. So crystallization is used when you want to get your salt and you know that that salt is sensitive to heating. Then we looked at chromatography. Chromatography is a method we can use to separate a mixture of movement in a solvent over an adsorbent material, say paper. There are different types of chromatography. You can have what we call paper chromatography or column chromatography. For paper chromatography, the adsorbent material is filter paper, and a variety of solvents can be used, such as ethyl ethanoate or ethanol. These methods can be used to separate dyes in blacking. The method to use is chromatography. Now we have fractional crystallization, and this is used to separate two or more solid solutes which are present in the same solution in roughly equal amounts. So once they are present in roughly equal amount, use fractional crystallization. Solubility of the different solutes in a given solvent at different temperatures. Okay. Okay, that's where we're going to be stopping. So that in the next class we'll be looking at chemical combination. But before that, I'm going to show you some past questions and also some pictures of these separation techniques. Okay. So we all know that separation techniques is the method employed in separating mixtures. So these are mean by the nature of what you want to separate. So let's say you want to separate solids of different sizes. You get your rice in the market. You know, we have two types of rice in the market. We have the Nigerian rice and we have the foreign rice. The foreign rice is the type that there are no sand inside it. You can easily buy them and start cooking and using. But the Nigerian rice, plenty sand. So how do you separate the sand from the rice? You can use sieving. Because most times the size of the sand and that of the rice, they are not the same. You can also use hand picking because you can easily see the difference between the shape of the rice and that of the sand. So you can use hand picking for that. Then number two, we have what we call magnetic separation, where you can separate a magnetic solid from a non-magnetic one. Sublimation, we've already looked at that. A solid that can sublime from the one that cannot. Then we can also look at decantation, filtration, and centrifugation, which we can use to separate insoluble solids from liquid. Insoluble solids from liquid, you can use decantation, filtration, or centrifugation. Any of these, mostly decantation and filtration can do that. Whereas for soluble solids from a liquid, you can use centrifugation, evaporation, crystallization, and fractional crystallization. Okay, use distillation for solvents, separating solvents from each solution, fractional distillation for miscible liquids of close boiling point. I've said that before. Then we can use separative funnel to separate immiscible liquids. Example of an immiscible liquid is liquids like petrol and water. Petrol and water, or oil, palm oil and water, they cannot mix. So once you put them in a separating funnel like this, so you have the one of lesser density up, the one of higher density down. So through the mouth here, you can easily discharge the one of the higher density. Then once it gets to the ones of lower density, you can turn off your tap and they will remain in the separating funnel. Okay. So now we look at chromatography solutes from solution. I've already explained that. So this is a typical diagram of fractional distillation. So we have the liquid that you want to separate, you heat. So the vapor comes up. So depending on the temperature, it can cool and go back. You collect your distillate. So vapor of the substance with the least temperature will evaporate first, get separated, then others keep coming out. And that's how you can separate this is actually what happens in the refining process that you use in refineries for getting your petrol from your crude oil. Then this is what we call decantation. So you can see the mixture, the sediment is here. So you can just decant the liquid, leaving the sediment there. So this is a typical diagram of decantation. This is what we mean by centrifugation. Then this is crystallization. Crystallization is used for substances of salts that can easily decompose at high temperatures of heating. You don't want to heat them much. This is precipitation. This is distillation. So distillation, little bit different from fractional distillation. It's more detailed one. Okay, this is a separating funnel for separating immiscible liquids. You can see this is the oil, less density. This is water, higher density. So the water will run off first, then you turn off your tap so that the oil will remain inside the separating funnel. So this is the diagram for chromatography. Like I say, it could be paper chromatography, which is what is shown in this diagram. Could also be column chromatography. Okay, this is another sketch of fractional distillation. So take note. You always have the condenser that condenses the liquid. and get them back into another funnel. So now let's give examples of substances that can be separated with a given separation technique. Like for sieving, you can separate Gary particles with that. Magnetic separation, magnetic impurities from iron ore. You can use sublimation whenever you have substances like iodine and ammonium chloride mixed with other substances because they can sublime. Decantation can be used for chalk particles in water. Filtration, suspensions of chalk, centrifugation for Gary and chalk particles. And lastly, evaporation to dryness for salt solution, distillation for distilled water. Use distillation to get your distilled water that you use for special purposes in the lab. Fractional distillation is used for petroleum and crude oil. And chromatography for colored materials. So that takes us to the past questions. Let's look at the past questions. So we have JAMB 2020. Question number 9. Question number 19. Okay, so let's check out how we can separate a component of ink and water and iodine and sodium chloride. I think this question is not very clear. I'll get the scanned copy. The question is not very clear. I'll get the scanned copy. Okay, let's look at this one. Question 20. Which of the following procedures will separate a mixture of sand, sodium chloride, and iodine into its components? We have option A, add water, filter, sublime, and evaporate. And option B, add water, sublime, filter, evaporate to dryness. Then option C is sublime, filter, add water, filter, and evaporate to dryness. So first of all, we see that you're having a mixture of sand, sodium chloride, and iodine. So first of all, since iodine is there, you know that iodine can sublime. So let's do sublimation first so that we'll take out iodine. We take out these iodines first using sublimation. Then once you've taken this out, you know you're having sand and sodium chloride. Sand is not soluble in water, but sodium chloride is soluble in water. So add water in order for you to separate them. So once you add water, sodium chloride will dissolve, whereas sand will not dissolve. And since you have one that is dissolving and one that will not dissolve, you cannot do filtration. So using filtration, you can filter out your sand, leaving only sodium chloride and the water in which it is dissolved. So the next thing will be for you to evaporate to dryness so that all the water will go out, leaving your sodium chloride. And that makes us on C, D, and D the answer. Okay. So let's move forward. Now we have question JAMB 2017, question 19. A mixture of sugar and sulfur can best be separated by dissolution in water followed by dash. So how can you separate a mixture of sugar and sulfur? The mixture of sugar and sulfur can best be separated by dissolution in water followed by what? So after you dissolve sugar and sulfur in water, what are the next things you can do to separate the mixture? Is it by 1, filtration and evaporation? A. B. Decantation and filtration. C. Centrifugation and evaporation. D. Decantation and evaporation. Okay, sugar is soluble in water, we all know, but sulfur is not soluble. So the mixture can be separated by dissolution of the mixture in water with the aim of dissolving the sugar, leaving sulfur behind to be filtered, and we recover sugar by evaporation. So we'll talk about filtration and evaporation. Okay, so let's move forward. Petrol can best be separated from its mixtures by what? So I believe this one is pretty simple. Oluwaseyi, can you answer this question? Which of the following methods can we use in separating petrol from its mixtures?
Fractional distillation.
Okay, that is perfect. That's option D. Okay, let's look at the last question. Second to the last. A mixture of petrol and water can be separated by, I think this one is also simple. Petrol and water, they are two immiscible liquids, so you can use separating funnel for that. And finally, for today, sugar is separated from its impurities by A. Precipitation, B. Crystallization, C. Distillation, D. Evaporation. So sugar can always be separated using crystallization because sugar is sensitive to heating. Okay, that's why you cannot use either distillation or evaporation for that. Okay, so with that, we'll come to the end of the class. And in the group, we are going to be, if you have any questions, you can send them in. This class was pretty long. It's longer than the physics class. So I'm going to be signing off immediately so that we can quickly put ourselves together and join up for the next class. See you when I see you. Thank you. God bless.